All right. So I think we're ready to get started. Again, good morning, everyone. Glad to have you here this morning. We're going to get started pretty quickly. My name is Edric, and I'm the marketing coordinator here at Fuse Forward. I'd like to welcome you all to episode 12 of our webinar series, Remote Control. I'm really excited for today's topic. We are taking a look at how we can modernize your enterprise asset management systems. Presenting today, we have Mark Dam, our Chief Technology Officer. And that's pretty much it for me. So I'm really looking forward to today's show, so I won't take any more of your time. So over to you, Mark.
Thank you very much, Edric. Today's show, it sounds like we are on it's kind of a new series for us. We've 12 months in. We started this at the beginning of the pandemic. We are hopefully going to continue it as we move forward, going forward. I think it's been a lot of good information for everybody going forward. So today, I want to talk a little bit about enterprise asset management and how to modernize your system. Give you a little background. I basically have been building enterprise asset management systems for about 20 years. So now the key question is how do we go through and take what we did 20 years ago and bring it into the modern age? And some of the things that we can do around quick wins and opportunities to go through and build big solutions around that. We're going to share with you some of the ideas today on what we think are some ways to do that. Before we jump into the details and contents, I do have a little poll that I'd like to kind of ask. If you kind of see the poll popping up, what features, functions would you like to see from your EAM system that you may not have today? So we got things like mobile enablement, spatial enablement, real-time streaming data, artificial intelligence, augmented reality, or other. Things that are near and dear to my heart, that's for sure. So results, real-time streaming data by far is the key driver for that. So that's interesting. One of the key topics we will be talking to today is specifically around streaming data and what all this means for streaming data. So thank you for that. Well, let's jump in. I've kind of got a little bit of a context today. Is this your EAM system? So I've kind of looked at it over the years and said, okay, what does it look like? How do these things work? So is your EAM system strictly being used for equipment tracking? In fact, some of the first EAM systems that we basically were working with were computerized maintenance management systems that we added functionality to track assets. And what they were focused on was just getting an inventory of the assets, not even down to component level. They had limited functionality. They were really geared towards just tracking a maintenance job or predicting or basically looking at, say, oil changes for pumps. And they had limited functionality. And in some cases, the things that they were only used for or currently used for could be work orders, service tickets, managing the services around it, and then doing job costing. In some cases, job costing was what I would consider about 20 years ago an expansion of the EAM, which was actually getting into activity-based costing. But if that's your EAM system, let's go and look at it. It's like, what's stopping you from moving forward? Are some of these kind of hitting you? You know, is it basically you've got a system like an Oracle EAM or a Maximo or even an Infor product that might be out there? Are you currently using it on premise? Is it a tool in a facilities world like Archibus, which is still running inside your facilities management department? Or is it legacy? It doesn't have a lot of configurability to it. The data in it's there, it's very stale. Do you have limited budgets right now and lack of integration? Is your system a standalone system right now and it's not integrated with your SCADA systems? It's not integrated with your building management systems. It's not integrated in with your building blueprints and your 3D models. Is the functionality only good enough? You know, one of the things we hear a fair bit is, you know, it does what it needs to do and we don't really need to change it, but it's good enough for what we're doing today. Because we're not necessarily, but going back to that comment on the poll today, streaming data, wow. If we look at some of the things that are coming down the pipe, what's the future going to look like? There's a lot of opportunity for improvements that we can drive that are leveraging that data set that exists inside our EAMs, the inventory of the assets, the work orders that are out there, the people doing the jobs against the work orders, the preventative maintenance schedules, the standard operating procedures. Now, how do we go through and get more value from that? What is the next wave? What are the things that we can do to modernize? So what we think of when we think of modernization, we think of intelligent EAM systems. So there's a journey that goes along with this. And I'm going to share with you a little bit of what I think of as an intelligent EAM system. So some of the first systems we ever put in was basically go through and implement work orders, service tickets, get the asset inventory, do condition assessment around the assets, and get into the basis for doing preventative maintenance programs. That was a big step forward. Then we start working forward to say, okay, now that we've got this base set of data, what else can we do? Well, the things that trigger our preventative maintenance programs are data coming from the operational parameters, the operational systems. So let's start linking things together. But then we want to start analyzing it, degradation curves. Is there a way that we can look at a pump, feel about the vibrations, determine what the vibration patterns are, and determine if there's a failure point coming along because the vibration is changing over time? So those are the kind of things that we start creating intelligence to the data around the EAM. It's not using that static data that's coming every day or every week and just doing these visual inspections, but it starts getting into more and more data coming in that we can look at real time and use them for decision support. And not only for decision support, but for going through and predicting and getting into that whole area of forecasting, prediction, and simulation analysis. So I'm going to talk you through and walk you through that process here. So we've kind of looked at the future and said, what's the journey? A lot of cases today, we have got our base system. It's on premise. It could be in a single plant environment. We now need to link it in with the data from other plants, other facility areas, or even compare our data to other organizations. One of the key ways to do that is to start cloudifying the work order systems and cloudifying your mobile applications. So migrate your EAM to the cloud. What does that do? It means that it's available anywhere, anytime. People working from home, people working as a virtual organization can go through and get access to the data sets there. Always issues and questions around that. How do you secure it? We have a separate webinar series talking specifically about securing it all, but we can share that later. That's part of the work that we've done and some of the information that we've shared on other remote control series. The next phase, we start looking at this, and one of the things that we've done over the years is look at how to integrate in spatial data. How do we create 3D blueprints on top of the work order data? How do we go through and bring all that together? How do we bring in the data from the streaming building information management systems and the SCADA systems and bring all that together and integrate that? That's where you start getting into those two more steps. Augmenting your EAM with data marts and data lakes that contain that operational data. Start integrating in that real-time streaming data sets. Once we've started creating that visual context to all that streaming data, we can start getting into that third tier. That third tier is advanced analytics and real-time dashboards, and we start getting into the intelligent EAM solution. What do we start getting that? Once we have all of that in one place, we start creating an ability to go through and do predictive analysis, create autonomous controls, or get into ability to bring the two together and say, if I've got an AI and I'm able to go through and get some patterns and look at what's going on, I can predict failure of my assets before they happen. Or I can start optimizing my environment and set my set points correctly on my power plant or my water distribution network or whatever that might look like in the EAM world. So 3 steps. I'm going to walk you through a couple of scenarios and things that we can do. Let's talk about that journey. Cloud integration, data integration, and data management, and all of the pieces that go with analytics. So I'm going to walk you through a couple of those opportunities and what you can do to get started, quick wins as well as larger pieces to get you going. So the current challenges that we see with EAMs today. Many organizations are working with, say, an on-premise environment. They say, you know, I want this to become a corporate standard. What do I need to do? I can't scale it if it's sitting in one place and I don't have connectivity in all my other plant environments. How do I bring that together? Or I'm working on one of the old legacy products, or the product is on a version which is 3 years old or 5 years old, and I don't have that capability to go through and add that additional functionality to it. So what do I need to do on that with on-premise limitations? Or I'm at the point where I've got to go and do these upgrades. I've got all of these high operational costs because the ID department that is supporting us on doing these upgrades or changing the underlying infrastructure is costing us a lot of money. And they're very limited dollars. How do I go through and manage that budget and get budget together in order to do this? Is there ways that I can do this quicker? Is there ways that I can start small to get some pieces going? So let's talk about the cloudification process. Okay. One of the things that we look at with delivering applications in the cloud, as an example, the cloud can be many different things. It could be an environment inside AWS. It could be an environment in Google. It could be an environment in Azure. Or cloud could be a scalable infrastructure that's hybrid that's sitting on premise as well. It's what we call a hybrid cloud deployment. But once you've got that scalable nature and you've broken your system down technologically into a lot of smaller parts, we have the ability to go through and create connectors into it. And once we have those connectors, there's things that we can store and do with our cloud system once we start creating what we call application programming interfaces or integration points around it. We then can start creating things like digital services. So one of the things that you have once you started creating it and you create a layer of communication around our connectivity to it, we can start putting chatbots on top of our EAM system. What does that do? Well, it means that our customers no longer have to type in service tickets. They can basically interact with an online chatbot and go through and enter in the information that way and get some self-service capabilities going. So that means it expands our ability to get it. We can basically put a chatbot for our consumers, for all of our end users, so they can go through and say, you know, I've got a problem. I'm noticing something out in the field. I can talk on my phone and I can go and share that information in. The other thing we do with the cloud is we get into this area of remote operations. Remote operations allows us to go through and still use smaller distributed operation centers, secure, lockdown, not connecting over the internet, but through private networks, but allows smaller distributed operational centers to basically run our infrastructure for us. So that allows us to get into remote operations. Doesn't need to be in the plant. It can be outside the plant, but it can still be in a secure area in a region. So as an example, in a large distribution grid, that might be cross-country, cross-state, or cross-city, or cross-province, you can basically create it in 2, 3, or 4 different locations, and they can basically back each other up at different time zones, if it is national. Or it could be just regional, so that people don't have to travel as far to get to their operational shop. It creates that whole hybrid model of remote work. The other 3 areas we look at are things like IoT, Internet of Things, artificial intelligence, AI, and machine learning. It used to be called ML. So we got these big acronyms, IoT, AI, and ML. Now those 3 all have kind of a component together. As soon as we cloudify our application, provide an integration point into those data sets, we can plug in these new services that are available from other providers. Things like taking the IoT sensor data and plugging them in. New sensors can talk in, start giving us data. AI, we can start our machine learning. We can start looking at the data inside our EAM system, and we can start going through and looking for patterns. Once we see patterns, we can create machine algorithms that can basically react to changes to the patterns. Things like a building management system with a dynamic set point. If I'm getting data and I'm looking at temperature changes in my HVAC system, I can start going through and adjusting those, look at what the changes are, how the system operates in regular situations during the day, during the afternoon, during the night, and I can dynamically go through and change the set points to go through and turn on and turn off the HVAC systems in a dynamic set pointing model. Same ideas apply to things like power systems, or even your control systems on your pumps. And then once we get into AI is the ability for those things to start learning more and more from themselves, and we start getting into autonomous control systems. So, but once we get into the cloud, we start creating that environment, starts giving us the ability to put APIs or application programming interfaces and data connectors around it, and we can start going through and expanding these new services. So we start going through and creating these, and each one of these is one small little project. So it becomes a quick win. So you can start with a little chatbot. Doesn't need to be a big project. It can be a smaller one. And once you're using cloud services and you're allowing your system to communicate to a cloud service, you can then go through and use a third party or other sort of cloud services which are easy to deploy and quick little projects to get you started. So that gets us into a little bit of how do you get started then to get to the cloud? So you can go through and say, you know, I want to move my system to the cloud, or I want to go through and make sure that it's got that application programming interface around it. So start off with proof of concept in the development environment. Take the system, take your test environment, take your development environment, and do a little piece around it. And plug in a little chatbot just to that. And say, you know, that could be done in weeks. In weeks, and you can say, hey, look at this, it's all working. Once it's all working, you validated it, then you start looking at how to go through and roll that out to your customer base and work with IT and the corporate IT departments to roll that out. Second part, tie it into a migration of your software functionality upgrade or your system replacement. So a number of our customers that we work with, you know what they've been doing? It's like, I've got a big system upgrade. I'm going from version 7.1 to 7.2 to 7.3, and I'm going to do a technical upgrade. But as part of that upgrade, I can basically migrate it or cloudify it in order to do that. And once you do that, it's basically even the vendors themselves are providing more and more of their technological change through an upgrade cycle. So it becomes more part of their automated upgrade processes to go there. Again, smaller projects, not big years of work, but months or weeks of work to go through and get you started with an upgrade. And then you've got that capability and that core foundation in place. The other one is integrate with your on-premise systems. So part of the other one to get started on this one is, all right, how do I go through and augment with the chatbot? I've already talked to that, but we can even get started small enough with the cloud to start looking at plugging in those analytics services. So again, how do we go through and get started? Start small, link it into another project, do a proof of concept, or start with a little pilot project. All right, one of the things I've always looked at is the biggest thing that I've kind of seen today. I've been out there chatting with a whole bunch of customers and prospects and industry partners over the last 4 months. And one of the common themes that's been coming out from all of those conversations, I've been asking, it's like, where are you at? How's your data sets? What are you doing with those today? And what everybody has been saying is, I've got my EAM system. I've got a system tracking work orders and assets. But the challenge I'm running into is that my data is not in a good shape. Okay, so we start running into is how do we modernize our EAM? Well, part of it is maybe there's no technology requirement changes done. Maybe it's strictly a data management issue and things that we can look at. So what are some of the challenges that I've been hearing over the last 4 months? Number one, all the data is in different formats. I've got data coming from my GIS system, which is in GIS format. I've got data coming from my building management systems. It's in proprietary format from Schneider Electric or Honeywell or somebody else, and it's all proprietary. I have data coming in from my production systems, and it comes from their own production systems and their formats. So it's all there in different formats, and none of it's aggregated, none of it's in the right format. The other part is a lot of these systems, they're not talking to each other. I got my SCADA systems over here. I got my GIS and my building management systems over, or my building drawing systems over here. And I've got my work order tracking systems over here. They don't link in with data standards. The data is all in these siloed applications. Part of this is it's also not linked in any standards. One of the challenges we've run into is there really a standard out there for different kinds of asset definitions? We got accounting standards. In the US, it's called FERC, for the Federal Energy Regulatory Commission standard for tracking energy assets. Okay, there's the United Nations Standard Product and Service Catalog for products and services, but it doesn't touch it. For construction, we have RS means. But there's all kinds of different ones, and there's all of these different data standards out here. And we're always trying to figure out how do I compare my performance and my systems to other partners or other organizations for benchmarking, for degradation modeling of assets. So all of that is a data problem. It's a problem of trying to figure out how to go and structure all of that data. So how can we go through and look at the solution to try and bring that together? One is putting the data into a data lake. Okay, so we bring all the data into one place, but if you look at these little arrows on here, that little arrow process is what we call a normalization process. So as you're putting in that data into a data lake, what you're really trying to do is link it together into one place so that we're starting to create the data sets have references to each other. And that reference uses a technology called an ontology or a taxonomy. It's the same thing we use in libraries when we go and name all of our books. So when we go through and we have the Dewey Decimal System, it is a taxonomy structure, or we have Darwin's way of classifying all of the different animals on the planet. It is a way of creating a taxonomy around stuff. So we want to do the same thing to our assets. We want to do the same thing to our services. We want to do the same thing to our systems, and how we bring all of that stuff together into that kind of ontology and taxonomy structure. What that does is it then creates value from your payroll data. It means that it turns your labor, and you can look at a trade from your payroll records and say, how much are we paying Or how much and what productivity and utilization rates are we getting out of our electricians? Electrician, good taxonomy. Asset usage. Well, now I can go through and take my reading data coming from something like a piece of equipment, a pump for a water utility and a water system, and I can start comparing my pump in a water system compared to other pumps in other water systems, and I can start looking at its classification, its structure, its horsepower and everything, and compare its performance to other pieces. I can start looking at my work order data and comparing all the work that I've been doing to things like, all right, how much is it costing me to go and do, and what's the performance for actually doing specific maintenance jobs like an oil change? That's the work order data. How long did it take to do the oil change? What resources did I need? What was the average unit cost to do that job? And then I can start correlating that to the weather. And what I can start taking is that work order data that turns into performance information, and I can start overlaying it and comparing it to things like, all right, how much did it cost last week to do that same job when it was raining outside compared to last year when it was snowing outside compared to the year before that when it was sunny? And is there a difference based upon these external factors on how our crews are working out in the field to do that? So those are part of the things that we can start doing by pulling all that data and getting a data management and structure in place and modernizing and grabbing more value from our EAM data that's sitting in all those EAM systems. Put it into the data lake, link it in with the data from all those other systems out there, and then start looking at the performance information that sits on top of it. So what happens once we do that? Well, we start enabling what we call the virtual operations environment. That means that anybody can start looking at this from the executive to the manager, to the operator, to the field crew, to the superintendent, to the supervisor, to the HR department. And we can start looking at all of this in a different realm with our different lenses on. So what does that do for us? So we start creating this common data lake environment. We're able to do situational analysis. So for an operator, I'm sitting out there in the field and I'm sitting behind my desk, and it's my virtual desk, and I'm sitting in a physical location, which is, say, in a physical operations center, but it's one of 5 in a region, and I'm there seeing what's going on. And it could be that we basically had a major accident over and a power outage in one of the other ones, but I'm in my operations center and I'm still operating. And I want to go and see what's going on with the electric distribution network over in the other facility area. Or I can start looking at that. And from that, I'm able to go through and pull in my power usage. I'm looking to be able to pull in my data from my customers. I'm able to see all the outages going on in those different regions. And I'm able to overlay on top of that, say, if there's any problems with the water system, I'm able to oversee and see where all my field crews are, and I'm able to go through and look at where any sort of other emergency or safety personnel might be if it's a major catastrophic event. Think about things down in Texas when they had the snow a few months back, and it was like, how do we go through and move all the people around? How do we look at all the grid failures, and how do we manage all those when we don't even have power to our operations center to run the grid? So that's situational analysis. It allows the operators and all these different ones to be working from the same pane of glass. The other thing with the data lake is we start getting into the ability to do predictive analytics. Things like, if I can forecast and predict what's coming down, my vibrations on my generator, and if there's changing in the vibrations or harmonics are changing, I'm sitting here saying, well, there's probably something wrong, and we're probably going to have to change some of the screws or change some of the calibrations on the device. And that gets us into the predictive analytics is the ability to see those nuances of harmonic changes, be able to go through and say, it's not a big one, it's got small changes. And as we start seeing more and more change, we're going to go through and say, it's going to predict that once it gets to this amplitude, and we're starting to see the amplitudes changing, we're going to get to a certain point where it's going to get into a catastrophic failure. So we want to catch those things before. That's predictive analytics for the assets. And you can start leveraging the data in that data lake to help you with that prediction forecasting. The area that I get excited about is this area called digital twins. Digital twins is not only taking that predictive analytics, that situational analysis, but then taking all that data and overlaying it on 3D and 4D blueprints, models of the actual physical world. Why? Because I love putting on my glasses, virtual glasses here, the virtual reality glasses, and being able to go through and walk through all of those different environments and seeing it in context. And context is important. We always started out with tabular data sets in our views on our screens. Then we went to 2D models where we at least have the floor plans. Now we're into the world of 3D. 3D is even more, because once we have those 3D environments, we also start getting into 4D. And the 4D digital twin environment means that we can start overlaying our predictive analytics and our situational analysis over top of those 3D models and those 3D virtual simulation or 3D representations of our plant environments and our distribution grids and our campus arenas. And what does that do for us? Well, then we start getting over to the last one. The last one for me is artificial intelligence. Once we start having those digital twins, we then have, and I always look at artificial intelligence is that whole advanced decision support tool. I'm not of the mind that we're actually going to have an AI going out here. It's kind of Skynet from the days in the movies. Skynet's out there. That's scary. We don't want Skynet to come at us. That's the ultimate AI. But as a decision support tool, it can start looking at patterns. It can start formulating and creating 3, 4, 5 scenarios that the operators, the managers, the superintendents, the executives can look at and say, all right, this is what we think is going to happen. Now you're going to have to choose, and we're going to have to interrupt the AI. But the AI is always going to be looking for patterns, always going to be looking for ideas and things that can happen. And they're always going to be there and saying, you want to be aware, you want to be aware, you want to be aware. That's the idea of an AI. Okay, AI should not be replacing an operator sitting in a plant where water treatment sometimes are doing it, but they should be able to be acting as your early detection systems to augment and support the operators to do what they need to do. So I've got a third area right now. And the third area right now is the real-time data integration. So in our polls at the beginning, one of the hottest buttons was real-time integration. So you know what really excites me here, and I do get excited if I get standing up, it's even more. But I think of the IoT sensors that are going on out in the field and all the data that we can grab from IoT sensors. What is an IoT sensor? It's these small, really cheap things that we can deploy out in the field, and they grab data for us. I have one on my wrist. It's called my Fitbit. It's an IoT sensor, and it tracks significant amounts of data on me every single minute, every single second. How much have I done my walk today? Is my heart rate doing well? Am I able to go through and make sure that I've been drinking enough water? Okay, it's got all kinds of information that is tracking for me related to me. Well, it's the same thing that we want to apply, and it's all real time. So one of the key things that we look at is what are some of the things that we have? Well, we're starting to deploy more and more and more of these. About 15 years ago, we started working on a project with smart meters, electric smart meters. And that was the first one. So we had the EAM systems. We started plugging in the EAM to the metering systems and to our customer information systems. And we started saying, how do we get more value from this? And then it was a large cost. Putting that meter out in the field and that smart meter, i.e. the digital meter, was a very costly exercise. And the meter itself was hundreds and thousands of dollars, not just in the way of the equipment, but the installation time to get it out there. Now we're getting into consumerization of device. Okay, the Fitbit, the smart home, the device that you can attach to an electric circuit within a submetering environment. We're putting in vibration sensors on all the pumps, putting in submeters, putting in air quality sensors inside our rooms, putting in flow monitoring environments, putting in in-stream quality control sensors. Challenge that we see with all this streaming data, though, is that there's no commonality to normalize the data or stream it at scale. Imagine now, we already have all these sensors out here. And the problem we identified is it's not millions, it's not billions, it's not even trillions. It's more than trillions of records coming in at scale that are starting to feed us information. We have this new thing coming out called 5G networks. They're all going to be linking in all of our autonomous cars. And each car is going to have hundreds and hundreds of metering points that are going to try and stream data through these wireless networks. Now that's streaming at scale. One thing we've identified is even when you stream at scale, the challenge is that you stream in 1 billion data points, and then you're going to generate a whole bunch of additional information from that, and it's usually a 10x on top of that. So 1 billion data points automatically goes 10x in the way of additional event records. And then once we do that, we then start doing our prediction calculations, which is even more data. And so there's always a challenge of trying to stay ahead of it. So we're generating this, we're deploying all that data collectors out in the field. Now, how do we manage it coming in at stream? So what we see is this whole need for an advanced analytics engine that can handle at stream. And I kind of started off with cloud. I went into a little bit of the data management and structuring the data with ontologies. And now the third part is now how do we go through and stream that data coming in? Now, luckily for us, there's a lot of other people that have already been thinking about this over the years, called financial services. Okay, and there's been a lot of work done at research labs at universities with the hardcore tech underneath, technology called Scala, okay, or sorry, not Scala, Spark, and where we can do streaming analytics, okay? And a lot of that technology is now being used by cloud providers, by other software vendors that are actually putting pieces around it, putting tools on top of it. That gets us the ability to create that advanced analytics engine. And that piece can be subscribed to as a service. And that's basically one of the key things about bringing these pieces forward. So you can start with the small little set of streaming data and start using a service that's available to handle the analytics streaming. And you can start creating real-time reporting, real-time, okay, as opposed to the data processing that we've done in the past, which is usually 72 hours to go through and calculate key performance indicators. Well, 72 hours is not good enough if you're trying to go through and find a contaminant in a water stream. Okay, if there is a contaminant in a water stream and I have a spectrometer out in the field, I want to know about it tomorrow or in the next minute so that I can turn off or change and find out where there is potentially contaminants before people drink the water. So that gets into that real-time environment, reporting environment. And what it also starts helping us do is it gets us into this real-time operational environment where we can start putting different kind of operational dashboards in place for operators that are sitting in their control rooms. So what's the benefits of real-time integration? Well, I think of things like simulation tools, okay? If I've got that and I'm an operator sitting behind my control desk, I want to be able to say, what if I changed this flow of this water pump and I started turning off these valves? What would be the implications of that? If I started to go through and put this breaker on and closing down this transmission or distribution station, what would happen? That's a simulation tool. It helps us to do that by understanding the real-time data. I can basically start looking at the locks and the different safety protocols out in the field and start looking at what happens if I change the system configuration on the fly. I can start getting into autonomous control. And what are some of the autonomous control methods? Well, I can put a little agent out in the field and basically reset breakers. That's still autonomous control. And we do some of that already today, but we have other ways to go through and do that at scale. We start getting into things like a real-time decision support tool, which I've talked to already a little bit. How do we go through and start now providing that single pane of glass, bringing in all of these different control centers into one view? Okay, we did a project with a campus, a university campus many years ago, and they had 11 different systems and one operator, and they had one chair that spun across in front of all 11 screens. And that was their way of doing decision support. And that's where they basically did not have a single pane of glass. They had 11 panes of glass. The only way they were able to correlate the data from all those 11 systems was based upon the operator's mind and what they were seeing in the visualizations across those 11 monitors. So how do we go through and create that so that we're now overlaying those different layers on top of a single pane of glass? So there you go. There's 3 things we can do to modernize our EAM system. We can go through and cloudify it and put APIs around it. Number 2, we can go through and set up a data analytics or a data lake so that we can start getting the data from all these disparate systems into one environment so we can do different things with it. Number 3, we can start integrating in real-time data into that and overlaying that and correlating it together to start getting into a single pane of glass. So let me give you a little bit of a case study now. All right, so let's say that we migrate to the cloud-enabled workforce. So we did a project with a large organization, And one of the things they had is everything was on premise, a bunch of legacy systems. It's kind of a theme that I'm sure many people have, because while I can talk about one, whenever I'm really giving a case study, I'm talking about 3 or 4 customers all combined into one, because of the same problem persists everywhere. It's like, I want to go and do this step, and then I want to go through and integrate in the mobility. Then I want to integrate in this. And we kind of look and say, well, what is the right for this organization? Where do you sit? What's the fastest way for you to get to value? So let's take this as an example. And this is a real world one. They have 1,600 customers across 60,000 locations, big facilities, okay? Lots of stuff that needed to be managed, lots of assets inside buildings. They needed to get the right engineer to the right job with the right tools at the right time. So if you're out there in the field and you basically show up, the largest cost to going through and managing a job in the field is not actually the pieces of equipment, but it's the mobilization to put the people on site at the time with all the right tools. The less time you have to go back to the yard to go and pick up another piece of equipment, the more time it takes out in the field. In an oil pipeline across a large geography, if you have to fly a helicopter to get a crew there, you want to make sure that you've got everything that that crew needs on the helicopter when you drop them into the pump station, so that they can do all the maintenance work and all the operational changes that they need to do without having to fly somewhere else back again, because the cost of transportation is one of the largest costs. Third one is you want to increase the number of jobs completed and reduce the worker travel time. So if I'm looking at a big geography, I actually want to go and get, this client wanted to get, I want to go and have this field crews, and I want them to basically be able to do not just 2 jobs in a day, but 3, 4, or 5. And I want to bundle them into that one region and minimize their travel time. How do we do that? So what was the application? So we had to put in a system. So we had to take all of those applications and bring them together and put them into one place. But some of them were SaaS products. So it was like, okay, we have to take certain pieces that we can do, bring them together into one. Then what we start doing is say, okay, well, we kind of migrated certain applications over, left some of the legacy stuff in place, take some of the legacy data, put it into the data lake, take the new systems, and then get them running with the new technology, and then plug all these different systems together so that we can basically go through and start dispatching work to field crews. Now, while doing that, that gets you to kind of like a phase 1. And then a phase 2, we go through and say, okay, now that we've got basically that basic work orders going, can we start going through and doing advanced scheduling? Okay, now let's start overlaying and seeing what's going on and start doing the optimization and create an optimization service on top of that. Okay. Then the third one is once we've got that optimization service, can we now start to go through and create that whole prediction environment, start using advanced analytics? So there's your 3 steps and the phasing of this. Phase 1, get your basic systems in place. Phase 2, start getting into scheduling and advanced distribution, or at least movement of staff and mobility around. And phase 3 is start adding in that advanced analytics capabilities. Okay. Now, what I always look at is advanced analytics. Is there stuff that we can do in quick wins across the whole project? And that's what we always promote for clients. So for some of our clients, this one transportation agency, we basically went through and made sure that all the key performance indicator reporting was done in phase 1. So it starts getting you into that point of getting all those different pieces done in phase 1, so that you're already starting to get value from the data as you're implementing work order systems, service tracking systems, building information management systems, etc. Okay. So those are some of the things that you see. I'm looking at my time. We always like to go through and try and keep these into about a 40-45 minute time window. But one of the things we look at is move your EAM to the cloud. So one of the things we look at is what are some things you can do? Any EAM system. Most people today have patterns, or what we call deployment patterns, to help get your EAM system. You can still create customs and you can still fully manage them. Those are kind of some of the things that we look at and things that we can do to help go through and run some of the EAMs in the cloud. Need help? Happy to go through and give you some information on how we do that as well. On that, I want to go and open it up to some Q&A here and see what we have in the way of any questions that we can answer for people on the topic from today.
Yeah, thanks, Mark. So we have 2 questions here. First, from are there any EEM systems that aren't appropriate for cloud migration, or can any application be moved to the cloud?
In my humble opinion, any application can be moved to the cloud. It's not a matter of if, it's just a matter of how. One of the things that we look at is a lot of people do what we call lift and shift. Let's just take all these big applications that sit on premise and just put them on big machines sitting in the cloud. That's not going to get you a lot of value, by the way. What you really need to be doing is looking at taking that big application and optimizing it for use in the cloud, and it will decrease your operating costs. So as an example, a big product like a Maximo, which has got a lot of components to it, you can split it apart into different components and run it on different machines, and that would optimize your cost base of running that application. So those are kind of some of the things that we look at.
Okay? Great. Second question here is cloud necessary for the creation of a data lake, or can you do it on premise?
You can do it on premise. So I like to define the cloud as basically an elastic compute environment, an elastic storage environment that runs on hardware. Everybody seems to think that the cloud is all virtual. Well, actually, it's not. The cloud is actually a set of devices that is storage, which is just storage, networking, and compute. Whether you deploy it inside your own data center or you deploy it on virtual servers provided by AWS, Azure, or Google, at the end of the day, a data lake is still running on that same underlying infrastructure, and you can basically use it to go through and run the cloud. Okay, so you don't need to be on-prem, or sorry, in the cloud. You don't need to use a cloud provider, but on-premise will work. It just requires that you have the underlying management infrastructure around the compute, storage, and network capabilities.
Awesome, great. We have another question here in the chat. Do you monitor health of asset, especially utility substations or wind parks or PV farms?
So interestingly enough, that's been a big topic of conversation in all of our discussions over the last 4 months. So asset health, yes. So part of that is from our background. Our background has basically been always looking and saying, what are those sensors and things that we can do? So a lot of it is more and more, it's looking at life cycle degradation on different assets. And even the ontology models and the taxonomy models can be extrapolated to anything, whether it's a utility substation, whether it's a PV farm, whether it's a wind farm. Those are just different devices, different assets, and the methodology and the sensoring technologies all feed the same data into the data lake for that same level of requirement and degradation modeling on the assets. It's a generic methodology and a generic set of systems, or sorry, shall we say portable or horizontal in their use cases. Okay, the ontology models are a little bit different, but at the end of the day, they're still made of equipment, components, and they all have a bill of materials, and they all have different measurement points and flexion points and electric and engineering constraints that go with that.
Great. Another question is about the smart campus, and it's just like, what do you do with the smart campus?
Smart campus. Well, you're going to get me on my passion here. Smart campus projects are an interesting part because what happens is when we look at campuses now, especially buildings, a campus environment is a mini city. I grew up working with city governments and their utility and engineering operations where we were dealing with water, wastewater, electric systems, underground infrastructure, transportation networks, parks, and buildings and building portfolios. When we look at a smart campus, it is a mini city. It has all of that, plus it has to deal with a lot more density of mobility of people because the students are moving dynamically between classrooms, and we also have residential complexes, and we also have, in some cases, industrial facilities on campus as well. So what we do in the smart campus is we look at where all that sensoring technology and pieces come, plug it all together, work on a different campus redevelopment idea, and say, what is the things that you can do? So number one, plug it all together. 2, create a virtual environment. 3, use that virtual environment as a new learning environment to teach new programs and classes. We can even use that as an operations center and start enabling an operations center with the smart campus so that you're able to command and control and monitor all the campus environments from your operations center. So those are all the different pieces. We then also look at campus redevelopment environments and say, okay, if you're going to go through and start building new buildings on campus or redeveloping your buildings or retrofitting them, what are some of the development standards you need to follow? What are some of the technologies you need to deploy? How do you want to set up your networks, your machine network, versus your public network for your students versus your corporate network, and how do you segregate them all apart so that they don't talk, so that they can totally still leverage common infrastructure but be segregated for cybersecurity reasons. So those are all the things that we also work on. We're working with organizations like Cisco on some of that software-defined networking, on how we go through and put all those pieces together. Hopefully that helps a little bit on some of that and things that we do.
Yeah, so that's great. I just want to say that we actually did a remote control webinar previously. I'll give you the link on the chat. Feel free to sign up for that form, and then I'll give you the link to the webinar itself, the webinar recording. Yeah.
And on that, I want to say thank you very much. Hopefully this was an informative session today, and I will hand it over to Edric to kind of do our final closeout. And hopefully I loved all the questions today and all the things that we could share.
Yeah, great. Thanks everyone for attending. As well, this is our 12th episode in our remote control webinar series. So if you like this episode, if you want to go keep updated with the next one, just go to fuseward.com/remote control webinar. Or you can follow us on LinkedIn. I think Serena will give you the links on the chat here for the upcoming session, and also if you want to keep updated with the company. So yeah, thanks everyone. And I'll give you guys a recording of this session through email as well. Yeah. Thanks, Mark, for your time, and thanks everyone for your time as well.
Thanks,
Take care,
everyone.